today's lesson in our section on laws of exponents is how to multiply monomials. So we are doing multiplication of monomials, which, if you remember correctly, is a number, it can be a variable, or it can be a product. That means multiplication, product of numbers and variables. So remember, we're just dealing with monomials. We're not dealing with any addition, subtraction, in between monomials. We are just working on multiplying powers. So let's start with the rule. The very first rule with the laws of exponents is how do you multiply them? They have to have the same base. So one example would be a to the m times a to the n. Notice that they have the same base, this a here. They must have the same base in order to multiply. So the base must be the same. If it's not, you can't do it. But if it is, and they have the same base, we're going to keep the base. So you keep the base the same. You are not, and I repeat, you are not multiplying the bases together. Keep the base, add the exponents. So our rule, a to the m times a to the n, is a to the m plus n. So we keep the base, add the exponents. So let's look at our first example. We have x squared times x to the 7th. Do they have the same base? Yes, x and x, so we're good to go. So we're going to keep the base, add the exponents. And it's okay to write out this step while you're starting on this track because it keeps you straight. Keep the base, add the exponents. So keep the base, x, and 2 plus 7 is 9. And so x squared times x to the 7th equals x to the 9th. Looking at a next example, we have a times a to the 6th. The first important thing to remember here is we have this a and there's no exponent. So what is supposed to go here? Well, a monomial that has no exponent, and you should write this down, that has no exponent, no exponent written, really has an exponent of 1. So my advice when you're solving particular problems like this would be to write out the exponent of 1. So this is a to the 1st times a to the 6th. Do they have the same base? Yes. So we keep the base, add the exponents. Therefore, a, 1 plus 6, is a to the 7th power. And you're done. Our next example involves more terms. But that's okay. They still have the same base. So what do we do when we're multiplying monomials? Keep the base and add the exponents. So I kept the base and I added all of these exponents here. So what is 2 plus 3 plus 5? A to the 5 plus 5 is 10. So our answer to this example is a to the 10th power. Example number 4 gets a little bit more complicated. We now have different variables all involved in this monomial and different exponents. So what is our rule? What have we been repeating over and over again? Keep the base, add the exponents. But it's a little harder to do. So my advice would be to group all of the A's together, group all of the B's together, and then group all of the C's together. So let's put that in order. We have a times a squared. We have b times b cubed. and we have C times C. Notice I'm not doing any math yet. I'm just putting the A's together, the B's together, the C's together. What's great about doing this is that then we have the same base, and remember, no exponents, so that means exponent of 1, exponent of 1, exponent of 1, exponent of 1. Now keep the base, add the exponents. Keep the base, add the exponents. Remember, we're multiplying. Keep the base, add the exponents. Now putting that all together, we have a to the third, b to the fourth, and c to the second. And you're done. So remember, group together first. Group all of your A's together, group all of your B's together, group all of your C's together, and then apply your rule of exponents. Keep the base, add the exponents. So this example gets a little bit harder because we're now including this 5. But again, same thing as example number 4. I want you to group all of your numbers together. Now I'm not referring to the exponents, I'm referring to the numbers. So this 5 here, I'm going to put my 5 together. I'm going to put my A's together. I'm going to put my B's together. I only have 1, so I'm going to leave that. And I'm going to put my C's together. Once we've done that, let's add in our exponents of 1 so that we know. And then finally, we're going to multiply. So we have 5, it's by itself. A, keep the base, add the exponents. B to the first, and then keep the base, add the exponents. So all I did was I regrouped. I put my numbers together that don't have any variables, my A's together, my B's together, my C's together. And simplifying that answer, we have 5, A to the 5th, B, or you can put B to the 1st, either answer is okay, and C to the 7th. Now I would like you to pause the video here and try this problem on your own. Remember, put the numbers together, put the A's together, put the B's together, and then solve. Hopefully you've tried this problem, and now when we go over it, you can check to see if you did it right. I'm going to put my numbers, 2 times 3 together, my A's together, A squared times A to the 3rd, and I'm going to put my B's together, B to the 3rd times B to the 4th. Alright, 2 times 3 is 6. A to the 2nd times A to the 3rd. I'm going to keep my base, add my exponents, and then for B, keep my base, add the exponents. And once we've done that, we see that we have 6, A to the 5th, B to the 4 plus 3 is 7, and you're done. If you got this answer correct, then you are starting to understand this. If you didn't, go back, keep trying these problems over and over again, and just remember, keep reciting to yourself, keep the base, add the exponents. Again, I want you to pause the video and try this problem on your own. Hopefully you've attempted this, and now let's go over it. I'm going to put my numbers together. I'm going to put my x's together. I'm going to put my y's together. And I'm going to put my z's together. Now, -4 times -8, we have 32. X to the, keep the base, add the exponents, 2 plus 1. Y to the 1 plus 2. And z to the 3 plus 6. So our final answer is 32, x to the 3rd, y to the 3rd, z to the 9th. And there you go. You are done. Okay, here's one of your truly challenging problems. If you can get this, then I feel confident that you understand how to multiply monomials. So pause the video, try again, and then when you're done, press play again. So let's put our numbers together. 3 times 4 times negative 2. I'm going to put my a's together. A squared times a to the 4th times a. And I'm going to put my b's together. B to the 3rd times b to the 4th times b squared. Having done that, I'm then going to start multiplying. 4 times 3 is 12, so I have 12 times negative 2. They all have the same base, exponent of 1 here, so keep the base, add the exponents, and then all the b's have the same base, so keep the base, add the exponents. Having done that, let's simplify further. 12 times negative 2 is negative 24. A to the 2 plus 4 is 6, plus 1 is 7. And b to the 3 plus 4 is 7, plus 2 is 9. So if you got negative 24, a to the 7th, b to the 9th, then you did this problem correctly, and you understand how to multiply monomials. But let's look at one more example. Here I have a rectangle. It has a length of ax squared y to the 4th and a width of 10x squared. I want to find what the area equals. Well, how do you find the area of a rectangle? Hopefully you're saying area equals base times height, because if you said that, you'd be correct. So let's put in my base, my length. That's 8x squared y to the 4th. And then my height, that's this height, 10x. All right, we're going to apply the same rules that we've been doing. I'm going to put my numbers together, 8 times 10, my x's together, and my y's together. I only have one y, so I'm good to go. And my area, 8 times 10 is 80. X squared times, don't forget that power of 1, x to the 1st, is x to the 2 plus 1, and y to the 4th. So my final answer here, my area, equals 80, x to the 3rd, y to the 4th. Very good if you got that. This is an application of multiplying monomials. It can become very useful later on in other math courses when you don't know what x is and you need to find different lengths and widths to get certain areas. So in summary, we learned how to multiply monomials, and we learned the rule. If we have a to the m times a to the n, we are going to keep the base and add the exponents. Very good.